We have 6 trig functions to define. We've only done one so far. Our second one is called cosine, written COS for short. Its output works similarly, but it's defined by taking the length of the adjacent side and dividing that by the length of the hypotenuse. So using the triangle from our same example, we would estimate that cosine of 35 degrees is about 7.5 over 9.2, which comes out to be approximately 0.82. If you divide the opposite side length by the adjacent side length, you get the output for what is called the tangent function, written TAN. The remaining 3 trig functions are the reciprocals of the 3 we've already seen. There's one called secant, written as SEC. That's the reciprocal of cosine. So that means the output of the secant function is hypotenuse over adjacent. A similar one, cosecant, written as CSC. That's the reciprocal of sine, so it's hypotenuse over opposite. And finally, cotangent, COT, is the reciprocal of tangent, adjacent over opposite. You might be wondering about the naming of these functions. They seem to be named in pairs. So what is the connection? Why is cotangent the reciprocal of tangent, but cosecant and secant are not reciprocals? Well, in any right triangle, the hypotenuse never changes. But the sides that we label adjacent or opposite, well, they depend on where our input angle is. In our example triangle, since we had a 35-degree angle, the other angle must be 55 degrees. And if we used the 55-degree angle as our input, the sides labeled opposite and adjacent would swap. So adjacent for the 35-degree angle becomes the opposite for the 55-degree angle. And if you now compute the trig function outputs for 55 degrees, you'll see that sine of 55 degrees is the same output as the cosine of 35 degrees, and vice versa. The same kind of connection happens with tangent and cotangent, and secant, cosecant. If you're learning trigonometry and you're doing some homework problems, you'll probably get some exercises where precise side measurements are given in a right triangle and an angle is indicated with a variable like theta, but we don't know exactly how many degrees the angle is. We can still compute the output values for the angle. We'll just write sine theta equals 4 over 5, etc. For the moment, we won't worry about what exactly the measure of the angle actually is. Once you are comfortable with how these trig functions work, you'll see later that we can work backwards and figure out angles if we have the triangle side length measurements, or we can figure out missing measurements in a triangle if we know the angles. These skills will allow us to solve a wide variety of application problems. There are actually 3 different ways to define the outputs for all the trig functions, and we'll do the other 2 in separate videos. The different methods give the same output numbers. They're just different ways of going about it. But for now, can you think of any disadvantages the right triangle versions might have? All will be revealed in the next video.